Hello there. We're going to talk today about probability trees. So this is the probability unit. We're going to talk about probability trees. You're going to identify and figure out methods of calculating the likelihood of chance events happening when multiple things are combined together. Like what is the chance that Stephen Curry can hit 1 out of 2 free throws if he shoots 90% for shooting 1? What is the chance that it will rain on 1 of 2 days if it's a 30% chance it will rain on either day? Contrary to what you might think, it is not 60%. If it's 30% chance on Monday, 30% chance of raining on Tuesday, it is not a 60% chance that it will rain on either day. And it's not 30%. It's somewhere in between, and we're going to learn how to figure that out today. So put on your hats, get out pencil and paper. I'm going to ask you maybe to try a few things here. So be ready to take some notes, try some examples. Watch an example or two. There'll be 3 examples, but we're going to start with a little bit of vocabulary. And without further ado, as we say, let's cut over to our drawing board. All right, so we're going to be talking again about probability trees, and some key stuff that we're going to need to start with here is we're going to start with some definitions. So we're going to start with some definitions. We'll put them over here on the right. Definitions. And the first one is sample space. And I'll kind of define it here, but I'll show it to you as we work through the examples. So sample space is a list of possible outcomes of one or more chance events. Okay, so that's what a sample space is. Okay, so for example, the sample space of flipping a coin. Well, the sample space is heads, comma, tails. Because that's the only thing that can happen when you flip a coin, heads and tails. Those are the 2 possibilities. Now, the sample space of rolling a die. So think about that. Rolling a die is a 6-sided die. We'll say 6-sided because some dies are 4, 8. We have some in class that we have of even 20-sided die. So the sample space of rolling a 6-sided die is 1, 2, 3, 4, 5, 6. We're not going to talk about the probabilities of landing on these just yet, but there's 2 possibilities, 2 outcomes when you flip a coin, and this is the sample space. 6 possibilities when you roll a die in the sample space is the list of things that can happen. Now, before we go too much further, I want to talk about one more thing. So we're just going to unwrap what we just did here. And I'm going to talk about the sample space of flipping 2 coins. And then we're going to get into probability. The sample space of flipping 2 coins is on the first flip, I could get a head or a tail. I'm going to do this a little bit differently than maybe you've seen before, but just bear with me and I think you'll get what I'm doing. So the first flip and the second flip. So on the first flip, you can get a head, but after you get a head, on the second flip, you can also get a head or a tail. And if you get a tail, you can also get, and this is kind of like our first choice. This is kind of the start. We can get a head or a tail. And then on the second flip, we can get a head or a tail. And if we get a tail, then we can also get a head or a tail. So what is this outcome? If we flip heads and heads, this outcome is a head-head. This outcome is a head-tail. This outcome is a tail-head. And this outcome is a tail, comma, tail. So here we have 4 outcomes. And so our sample space is head-head, head-tail, tail-head, and tail, tail, right? So we have 4 elements in our sample space. So flip a coin once. There are 2 members of the sample space, heads or tails, but flip it twice and we get 4. And you can maybe figure out what would happen if we flip it a 3rd time. If we flip it a 3rd time, we're going to get, we'll end up with 8 outcomes. But don't worry about that too much. If that's obvious to you, then great. If it's not, then we'll just, you'll see. We'll work some examples and it will start hopefully to make some more sense. So that's sample space. We're going to erase all this and let's just move right along. Oh, let's do one more thing of sample space. I want to let's do this sample space. This might be fun. This might really bring it home. Well, we'll do this in orange. We'll just change color, or reddish orange. Sample space. And here it is. So if for dinner, I can eat steak, chicken, or fish. That's my choice. I go to a restaurant and I can have steak, chicken, or fish. Those are the 3 things on the menu. And they have 2 things on the dessert menu. And what they have here is they have pie and cake. It's kind of a limited restaurant, but you'll see what I mean. We'll see how to do this. Okay, let's switch colors for our actual layout here. So our first choice is our dinner choice. And so let's lay this out the way we did the other one. So here's my kind of my start, and I can go steak, chicken, or fish. And then for dessert, if I get steak, I still can have pie or cake. If I have chicken, I can have pie or cake. And if I have fish, I can have pie or cake. So my sample space, I have 1, 2, 3, 4, 5, 6 things in my sample space. And all you have to do to figure it out is you just follow the tree. There's one choice. So my first is steak, pie, steak, then pie. My second one is steak, then cake. That rhymes, steak, cake. And my third one is chicken, pie, chicken, then pie, not chicken pie. Then I can have chicken, then cake, fish, pie, and then fish and cake. So there are 6 elements in my sample space. So notice that the first and second thing don't always have to be the same. So in my first choice, when I did flipping heads and tails, and in the second case where I did flipping heads and tails with coins, these 2 choices were the same choice or the same chance event, but it doesn't, in a probability tree, they can sometimes be one choice and then a totally different choice for the second one. Okay, so let's just erase all this one more time. And now let's go into how we calculate probability of chance events. And we'll start easier and we'll get harder like we tend to do. I'll do 3 examples. And if the first one's too easy or you totally get it, fine, just move on to the next one. And I think you'll probably at least want to watch the third one, and probably the second one and the third one pretty closely. The first one's going to be a little bit easy, but we're going to start easy because that's what we do. So here's the deal. We've just done this one. We're going to flip a coin twice, and then we're going to check or ask. We're going to find out, we're going to say, what percent of time, or what percent chance, let's say chance, do I have of flipping at least one head? Now, the way that we're going to do all of these problems is going to be the same. How to solve probability, how to solve probability questions using probability trees. The first is to build, you're going to identify the choices, identify the events. This can be, it can be one or more. Then two, we're going to build the tree. Three, we'll identify our outcomes. Four, we'll insert probabilities. For each individual event. And then five, we're going to calculate probability of each outcome. This is different than, I used the same list in class, the same concepts in class, but I think I thought it through a little bit better, and I broke it down into these 5 components. I think these 5 components actually make it even easier to think about. So don't hold it against me that I think I've improved on the question. Anyway, so what percent do I have of flipping at least one head? So let's look at our first event. We need to identify the events. Well, if we flip a coin twice, we basically have a flip number 1. Flip number 1. I'm just going to make this real easy to read. Flip number 1. Is that any better? And then flip number 2. Okay, those are our 2 events. So this is kind of like step number 1. Step number 1. Step number 2 is we build our tree. So on flip number 1, we're going to do our starting point right here. Flip number 1, we can do a head, or we can do a tail. On flip number 2, if we get a head, we can still get a head or a tail. And if we get a tail, we can get a head or a tail. Okay, let's identify the outcomes. Well, our outcomes, let's pop those in green just for fun. So head, head. So our outcomes are heads, heads. That's this one. This one is heads, tails. This one is tails, comma, heads. And this is tails, comma, tails. You know what? Down here on after number 5, and then we're going to use our numbers to answer questions. So after we build the tree and do all of the math, we actually have to answer, make sure, kind of 6 is we're going to answer the question. We got to make sure that we've done that. Okay, so now we've done number 2. We've built the tree. So 2 is, we've built the tree. Number 3, we've identified the outcomes. So that's 3. We've identified the outcomes. Number 4 is insert probability. So this is the new thing. So we're going to say, what is the probability of flipping heads or tails? Well, we know that just because we've been doing this in class a lot, and everyone knows it's 50% chance, that it's even chance of flipping a head or a tail. And now one thing I didn't say earlier, but we did cover in class, is that when you're doing probability, there's 3 ways to write probability. One is as a fraction, like 1/2. And we could use that here. 2 is as a percent, like 50%. And then 3 is as a number, as I did above. So 50% is 0.50, right? It's basically the percent with the decimal moved over twice. Now, the reason I use 0.50 is because you can multiply. We're going to have to do some multiplication. And we know that you can't multiply 50% times 50% without converting it first into decimals. And then you can convert it back to percent if you want to, but you can't multiply percents. Doesn't work. So, and you can multiply fractions. So we can either represent things as fractions or numbers in our probability trees, but we don't do it as percents. So we're not going to do percents. So you'll see. We'll do this over and over. It'll become natural for you. So if we flip ahead 50% of the time, on the second coin flip, the choice of getting a head or a tail is still 50%. 0.5, 0.5. And a head is 0.5. And a tail is 0.5. So the final piece. So wait, insert probability. So we insert our probability for each individual chance event. So if I, again, starting here, it'd be 50-50 going to this head or this tail. If I'm here, it's 50-50 of going here or here. If I'm here, it's 50% here or here. And I'm writing everything as decimals. So now we're going to calculate the probability of each outcome. This is step 5. And the way that we do this is the whole big aha, the new learning experience is all you do is you multiply these numbers. So we're going to say 0.5 times 0.5, and that equals 0.25, or 25%. Same here, 0.5. We're going to take this 0.5 times this 0.5. And you say, how easy is it? They're all the same. Well, they're not always the same. But in this example, they are. 0.25 times 0.25, 0.25%, 0.5, 0.5, 0.5, 0.5 equals 0.25 equals 0.25, 25%. Now, one way to check and know that you did this right is all of these have to add down. If you're adding as numbers, they have to add to 1.0. And if you're adding them as percents, they have to add to 100%. And the idea here is 100% of the time, I'm going to have one of the solutions, but any given solution is only a 25% chance. So now we have to use our numbers to answer the question. So let's do that in like this color over here. So our question is what percent chance do I have of flipping at least one head? So now we have to identify which outcomes have at least one head. Well, this one does. Well, this has a head. This one does. This one does. This one does not. So we're going to put a little X here. So these are our chances. So we have a 25% chance plus a 25% chance plus a 25% chance of getting at least one head. And the way you do it is to answer a question where you have multiple outcomes is you just add them together, because it's, if I have a 25% chance of this happening and a 25% chance of this happening, I have a 50% chance of either one happening. And then if I have a 25% chance of this happening, I have another 25% chance. So I'm going to circle all of these outcomes, and I'm going to say my chance is 75%. So I have a 75% chance of one of those things happening. And I have answered the question. I have a very good chance that I'll get at least one head if I flip a coin twice. Let's move on. You can pause this if you want, or go back and look at it. Stare at it. We're going to go through the same process, and we're going to start answering more difficult questions, ones that there's no way without a probability tree you can solve. Well, maybe if you're really good at these, you can start to do them in your head. I write them out all the time. There's other techniques for solving these, but the probability tree is the most natural way of doing it. Okay, so let's move on. So now we want to ask the question. And so we're going to switch into a case now where we're not dealing with 50-50 probabilities. We're dealing with 30% probabilities. So if I know the chance of rain, everyone's heard of this. The chance of rain today is, chance of rain, and we'll say on Monday, is 30%. And the chance of rain, chance of rain on Tuesday is 30%. So we're going to say it's the same percent chance, but it's not 50-50. So my question now, and I think you can probably guess where I'm going, is what is chance it rains exactly one day? Okay, so this is a little bit different. Last question was it would be get ahead at least once. So this is exactly one day. So we're going to have to look at our, after we build our tree, we're going to have to look at our probability tree and our percentages and our outcomes and make a decision about which outcomes meet this criteria. So let's look at this. Chance of rain on Monday, chance of rain on Tuesday. So how many different events are there? Well, the question one is will it rain Monday? And the second event is, will it rain Tuesday? And then we're going to have our outcome column. So question, will it rain Monday? So we're going to say, yes. So we'll just use yes. I'll put a little key here. Y equals rain. No equals not rain. So here we got our starting point. Yes and no. Will it rain Tuesday? Yes, no. We can do arrows. Let's do arrows. Yes, no. And we got another tree with 4 outcomes. Notice when we have two choices on, or two chance events with 2 outcomes each, you're going to always get 4 things. Basically, you're going to multiply those 2 numbers. Oh, learn something new. Okay, so the outcome here is yes rain, yes rain, yes rain, no rain, no rain, yes rain. New York, interesting. In. Okay, so let's look at what we got here. Let's write our probabilities. The chance that it will rain, yes, is not 50, it's 0.30. So if it's a 30% chance of rain, it's not a 50% chance, not a 30% chance, but a 70% chance of no rain. Okay, if it rains on Monday, the chance of raining on Tuesday is also 30%. So rain is 0.3, no is 0.7, yes is 0.3, and no is 0.7. Now, our outcomes, yes, is we simply take our probabilities along that tree, along that branch, and we say, well, that's 0.3 times 0.3. So the chance it'll rain 2 days in a row is 0.09, 9%. The chance of yes rain, no rain, is 0.3 times 0.7, 0.21, 21%. No rain, yes rain, also 21%. And no rain is 0.7 times 0.7, 0.49, 49%. Now notice, if we add this up, 49 and 21 is 70. 70 and 21 is 91. 91 and 9 is 100%. So we get 1 and we get 100%. So we've kind of checked to make sure this seems right. It's crazy though, you know, that 0.3, I mean, why should these four numbers add up to 100%? Well, we know they have to because math is perfect, but it's kind of weird, you know, 0.3 times 0.3 plus 0.3 times 0.7 plus 0.7 times 0.3 plus 0.7 times 0.7, that equaling 100%. We kind of know it has to, but it's kind of, you look at it and you're like, wow, that's really neat. Oh, math is perfect. All right, so we've calculated the probabilities. Now we just got to answer our questions. We've gone 1 to 5 without even thinking about it. So now, exactly 1 day. Is it yes, yes, exactly 1 day? No, this is not 1 day of rain. This is 2 days of rain. This is yes, no, this is 1 day of rain. This is okay. This is also okay. And this is no rain at all. So if we have 21% chance of this, 21% chance of that, we add them together, we get 42% chance of rain. You know what? I am so flipping happy. We're going to happy cat this. We didn't do happy cat last time. I don't know why not. I'm going to spin the happy cat because this is really cool. There is no way that you can kind of do this whole, it's really hard to do this in your head. I mean, why would it be 42% chance if it's a 30% chance of one and 30% chance of another? Using those two 30s to come up with the number 21 is not obvious how you do that. So this is very powerful stuff. This is stuff that's used in insurance. It's used as a critical piece of how casinos make money. We'll continue to talk more about this in later lessons about how important probability is. And people who know how to wield probability and build probability trees and calculate chance, they make a lot of money in this world. It's a very valuable thing. All right, let's get rid of our happy cats. We're going to go to one final question. And this one's a little bit more difficult. It's well, we'll see. I'll probably do some more probability tree questions with more complex trees. I'll do those in a separate video though. I want to do one more question at kind of at this level. And I want you to think about it on your own. And I'll kind of maybe break it at each point and make sure that you know how to do it. Or give you a chance to try to do it, I should say. So here's the deal. And bear with me. This is a good story. So Mrs. Lipscomb likes fries. Mrs. Lipscomb likes French fries. But like many women, she won't buy her own. Just won't do it. Okay. So here's the deal. We go to In-N-Out Burger. In-N-Out Burger. That's one, that's two. And the question is 60% of the time, 60% of time, Mr. Lipscomb buys fries. And 50% of the time, Liz buys fries. That's their daughter. Elizabeth, the daughter, buys fries. Okay, so only three. The three of them are going, so here's our three people, right? Our three people are Mrs. Lipscomb in the story, Mr. Lipscomb in the story, and Liz in the story. And Mrs. Lipscomb buys it. You could actually say 0% of the time. 0% of the time, Mrs. Lipscomb buys fries. Never buys French fries. Mr. Lipscomb buys them 60% of the time. Liz buys them 50% of the time. And so what Mrs. Lipscomb likes to do is she likes to poach others' French fries. French fries. So she bought. So what? So the question here is, what is the chance that Mrs. Lipscomb will have French fries to poach or to eat? What's the chance? Okay, so let's see here. So we have two independent events. And so I'm going to let you build the tree. There's two independent events. I'm going to give you a hint. Here they are. That could happen when we go to In-N-Out Burger, because everyone gets a chance to order. Mr. Lipscomb goes first. Liz goes second. Mrs. Lipscomb goes last, say. And something can happen. And those are our two events. So let's see if you can do this problem. Try the whole thing and see where you get. So pause the video, and then we're going to go forward. So now I'm assuming you've paused it. You've tried to build the tree, and you've built it. You at least have identified the events. Maybe you built the tree and identified outcomes. So let's see. Let's see. Event one is Mr. L buys fries. And the second event is Liz buys fries. And we're going to say Y is yes and N is no. Okay, let's do this in gold. Okay, so we start here and we say yes, Mr. Lipscomb, or no, Mr. Lipscomb doesn't buy fries. And here we go, yes, Liz buys fries, and no, Liz does not buy fries. Here we go, yes, Liz buys fries, and no. So we've identified our events, we've built our tree. Let's identify our outcomes. Our outcomes are yes, yes, both people buy fries, Mr. Lipscomb and Liz. Second is yes, no. Then we got no, Mr. Lipscomb does not buy fries, but Liz does. And then no, no, neither one of them buy fries. Okay, so let's pop down our percentages. Let's do that in blue. Mr. Lipscomb buys fries, let's see, 60% of the time. Liz buys fries, or no, he doesn't buy fries 40% of the time. Liz buys fries, so that's a 6.6. Liz buys fries 50% of the time and doesn't buy them 50%. Yes, 50%. And no, 50%. Okay, so now let's calculate the probability of each outcome. The probability that they both buy fries is 0.6 times 0.5. Yes and no is 0.6 times 0.5. No, Mr. Lipscomb does not, and yes is 0.4 times 0.5. And no for both of them is 0.4 times 0.5. So let's see if you can figure out why don't you pause it and make sure that you can figure out the probability of each event, and let's write those in, and we'll do those in this color over here. Pause it and see if you can do it. Okay, I'm assuming we're back and you've calculated these probabilities, and you've got 0.30, 0.30, 0.6 times 0.5, 0.3, and then 0.2, and then 0.2. And this is 30%, 30%, 20%, and 20%. And now let's identify the cases where we have some French fries that Mrs. Lipscomb can eat. That would be at least one of us buys French fries, and then Mrs. Lipscomb can poach out of either batch. So here's a yes. She can poach off of Mr. Lipscomb or Liz. Here she can poach off of Mr. Lipscomb. Here she can poach off Liz. And here's no. They both did not buy fries, so Mrs. Lipscomb has no fries because she won't buy them on her own. So 30 and 30 and 20 is 80% chance. So let's just say this. There is an 80% chance that Mrs. Lipscomb has a happy cat. Happy cat, happy cat, jumping up and down. He's psyched. Mrs. Lipscomb can have her fries and eat them too. So let us wrap up this this broadcast, and I might do another video with more complex versions.